what that means is frequency and wavelength are inversely related. All right, let's just rearrange this equation in case we need the rearranged version. If I wanted to find the frequency, it would be velocity divided by wavelength. If I wanted to find the wavelength, it would be velocity divided by frequency. And I'm going to add in here our other two equations that we have this unit already, is that period is 1 over frequency. We're going to need that. And frequency is 1 over period. Right? And I'll just write this up here. T is period, and F is frequency. All right. So if you want all the equations so far that we've had, this is it. You can take a screenshot of that or make sure that everything is written down. Speed of a wave, rearranged. And then from the other day, we know that period and frequency are related to each other. Period is how long it takes in seconds. Frequency is the number of waves that happen per second in hertz. Seconds and in hertz. All right, so using that information, we're going to do 2 sample problems, and then you're going to work on the wave basic problems on your own and finish up that simulation if you need to as well. All right, and I'll go back to this afterwards. If you want to come back to this after we do the sample problems, I'll put it back up on the screen. All right, so Lily, can you read that? Here, I'll pause it so we don't have to worry about people being. Thank you for doing that. So let's just write down what we have. As always, we have 500 meters per second. We have 0.035 meters. All right, and what we want to find is 2 things. We want to find the frequency, which is F, and we want to find the period, which is capital letter T. All right, sound wave is traveling 500 meters per second. We should know whenever it's meters per second, that's the velocity. And it says right here it has a wavelength of 0.035. So remember that weird symbol is wavelength. It looks like an upside down Y. We have wavelength labeled there. All right, so frequency. If we go back to our equations, we have 2 options. We have 1 over T, or we have F equals V over lambda. And since we don't have the T yet, we're going to use this. Frequency equals velocity divided by wavelength. The velocity is 500. The wavelength is 0.035. All right, and so that gives me a frequency of, I put my calculator away, 500 divided by 0.035, 14,285.7, and that is in hertz. That would be a really high-pitched noise. All right, so that's the first part. Now the second part says, what is a period? Well, period, we only have one option. We have to take the frequency and do its inverse. So we just take 1 divided by the frequency. So it's going to be 1 divided by 14,285.7. It's going to be a really small number. I have on my calculator 0.00007, and that's in seconds. All right, so here's how we'll do this. Sometimes you'll have to find the frequency and then go out and get the period afterwards, or it'll be the opposite, like our next problem, where they'll give you the period, you have to turn it into frequency, and then you have to use it in the equation. All right, any questions on that one? All right, let's do this last one, and then we'll be good to go. Leilani, can you read this problem for us, please? Great, thank you for that. Let's write down what we have. we have a period of, we'll just say 0.85 seconds for now. We have 6.5 meters per second, and we are looking for that. So it says, what is the length of the wave? That's wavelength. So we're looking for the wavelength. We know that this is the velocity, and it says it has a period of 0.85 seconds. It could say that every 0.85 seconds one wave goes by. That's another way to say that, and we need to make sure that we know that that's the period. It's the length for one wave, the length of time. Well, for wavelength, we really only have this option here, which is velocity divided by frequency. The velocity we have, 6.5. The frequency we don't. But we do know that frequency is 1 divided by the period. So we can do this a little bit of work ahead of time, and then we can fill it in. So if we go 1 divided by 0.85, 1 divided by 0.85 is 1.18 if we round it. Thank you. 1.176. So 1.17 is fine. 1.18 is a little bit better with the rounding on there. Thank you, Chris. 1.18. So now we're just going to go 6.5 divided by 1.18, and I have 5.5. Good, Carlos. 5.5, and that's wavelength. That would be in meters. All right. So we just made you do a little work ahead of time down here to go from frequency to period. Oh, sorry, from period to frequency, and then we were able to get that done.